All right, so we are going to go ahead and get started here. So we are going to start our unit on simple harmonic motion. Simple harmonic motion means things moving back and forth and back and forth and back and forth. So we're going to start that today with a quick lab about a pendulum, okay? And in order to talk about pendulums, we need to know what a pendulum is. So what is a pendulum? A swingy thing, yes. Yes. If you have ever sat on a swing and had somebody pull you back and let you go, you are a pendulum, okay? Where else have you seen pendulums?
Clocks.
Clocks, right? The little things on my desk. Absolutely. Where else? Anywhere else?
The pendulum lab we did.
The pendulum practice.
Pendulum lab. We didn't do this lab, did we?
No, we did. Yeah, we just swung a thing and a ball.
Oh, the ballistic pendulum. For sure. Yeah. So that was another one. Yeah. Anything else that you can think of? What's that? Absolutely a wrecking ball. For sure. Yeah. And all of this stuff kind of comes together. We're going to talk about forces and we're going to talk about energy and we're going to talk about all different kinds of stuff as we talk about this. But to start, we just need to define some things. So on your quick definitions here, you don't necessarily need to write tons of stuff down, but just so that we have everything written down, we are talking about things consistently. Where on this picture do you think the pivot point exists?
Arrow.
Where the arrow is, right? So write that down so you know it. Pivot means to go around, right? So it's where the pendulum is attached. Absolutely. What's equilibrium?
When it's at zero.
When it's at zero, when it's at rest, when its net force is what? Zero. Yeah. Equilibrium is the location where F net equals zero. Okay? You can also think about it just as its natural resting point. Where on the picture does the equilibrium exist?
The dash line.
That dashed line, that dotted line. Yeah. Because of air resistance, if I let a pendulum go and I just let it go forever and ever and ever, eventually it's going to come back and just hang right there, right? Yeah, at its equilibrium. Bob, not your uncle or whatever, but what is a bob in terms of a pendulum? Does anybody know? It's what we call the mass. I don't know why. I don't know if somebody, that doesn't seem like something that you get named after you, but literally that's what this thing is, okay? So the end of the pendulum where all of that mass is called the bob. I was just about to say, have you ever heard of Plumb Bob? Yeah, what does a Plumb Bob do? What do you use a Plumb Bob for? Yeah, to measure level of water. You can also use it like if you're trying to get something to hang level, or if you're trying to get something to hang and you want to know exactly where straight down is, okay? That is called a Plumb Bob. Plumb means perpendicular, right? So it's hanging straight down, perpendicular to the surface of the earth. That's what it's called. And that mass is where that phrase bob comes from. And again, I don't know the etymology of that, but that's what it is. So it's the mass on the end of a simple pendulum. And I'm not calling it a simple pendulum just to ease your mind or dumb things down. Literally, this is called a simple pendulum. You can have more complex pendulums if you have mass that is placed all along here, right? And you can also have physical pendulums that can kind of swing and shake, and there's not chaotic necessarily, but complex motion. We're keeping it simple for today. Yeah.
Can you make the bob a pivot point for another pendulum?
Sure you can. Yeah.
Then it will still be considered a pendulum.
No, but
it's more complicated. Yeah, it's a more complex system. Yeah. There are lots of those. There are lots of systems like that out there. Yeah. When you take classical mechanics in college, you will do that probably.
When you take
if
for
I
sure.
if I take
No, when you take it. Yep. All right. So those are kind of that's kind of the anatomy of the pendulum. These things that we're going to use to measure on the pendulum. So mass, it's the mass of the bob, or it's how much stuff the bob has, right? It's hard to describe that sometimes. For our pendulums today, we're going to use washers on a paperclip. And we're going to measure the mass of the washers on the paperclip. What units are we going to use to measure the mass? Kilograms, not pounds. That isn't even the right, the right thing. What is a pound a measure of? Which is it's a force, right? Pounds is a force. Yeah. Mass is measured in kilograms. Another thing we can measure is the length, right? How long the string is. What are you going to measure? What units are you going to measure that length in? Indeed. Now, is it okay to measure it in centimeters and then just convert them at the end? Yeah. For sure. Yeah. I just want to make sure that's really clear. All right. So these two are ones we've dealt with a lot. These two are kind of new. These two are ones that we're going to use now and then for the next, few units because they're important for these things. Amplitude. Have you heard the word amplitude before?
Yeah, like amplify. No.
What does it mean to amplify a signal?
Like
or to use an amplifier?
Make it bigger.
Make it bigger, right? So if you think about a sound wave, right? Or like you have a wave, like you're playing your guitar and then you use your amplifier. What does the amplifier do?
Louder.
It makes it louder. It makes that sound wave bigger. Absolutely. It increases the distance from the equilibrium point. Okay? So the amplitude is the maximum distance from equilibrium. Okay? So this is your definition for this. This is it. I'm not going to tell you this more and more times. So we're going to say right now, here it comes, that amplitude is the maximum displacement. That was a lot of happening over there. From equilibrium. Sometimes we measure amplitude in meters. Today we're not going to measure it in meters. What are we going to measure it in? You guys going to have a guess there? We're going to measure it in degrees. Yep. So we're going to measure theta. Yeah. So we're going to measure the angle. Because it's easier to measure an angle than to have to do the math to figure out the distance. What's that? You can, I suppose, if that makes your heart happy, do it. And then, we having a good day back there? Okay. And then the last one is not the grammatical or the grammar, thing. What are we talking about? What is period when we talk about physics? Does anybody know? How long, right? Period is a very specific measure. It's a measure of time, okay? And it's the time for one complete cycle. Okay? Time for one complete cycle. So the period of that pulsar spinning is very, very short, right? Yeah, it's how long it takes for one complete cycle. So I want you to think about this really quickly. If you've got a bob sitting over here, I've displaced it to an amplitude, let's say, of 15 degrees, and then I release it. I'm going to start the timer, go, and then tell me when I'm going to stop my timer.
No. There.
There, this. One complete cycle. Where does one complete cycle end, friends?
This.
Back at the beginning.
This, that, or the other one?
Or the beginning. No.
Goes down
It starts with something.
And back.
and back.
Yeah, right there.
Right there. Okay? Has to go down and back. Okay? One complete cycle. It's measured in time. So it goes down and back. So a lot of times, friends, I'm almost done with this and then I'm going to let you get started, but I need your attention. A lot of times I will say that it is when it returns to its release point. But I want to make that really clear because sometimes then I have smart alecky students who are like, oh, well then, like if I release it here, but then I'm looking from here, is it from right here up and back?
Oh, I see what you said.
See what I'm saying?
No.
It can't be just from here up and back. It's got to be, so if I start my timer here, I don't know why you would do that, but let's say you did. If you start your timer here, it's got to go up and back and then down. You with me there?
Yeah.
So it actually passed through equilibrium a few times, right? So I just want to make sure that's really clear. Okay. So I'm going to fill in this little last thing in just a second. But I want you to be aware of how we're going to do this experiment, because I want to make sure as we're moving closer and closer to May that we're preparing ourselves more and more and more for that AP exam. So what we're going to do in just a minute, we're going to get into some groups, and I'll explain that in a second as well. But I'm going to give you some time to discuss how you're going to do this. And then I'm going to give you 5 minutes. 5 minutes on the first day back from winter break, you're welcome, okay, to write down your proposal for how you would do this problem, how you would set up this lab. And I will post this up here. The reason I'm telling you this now is so that your conversation is productive in a little bit, okay? Because I want you to write down how you're going to define and select the variables, how you're going to control variables, and how you're going to collect your data. Does that make sense? So I'm going to give you time to talk. Then I'm going to have a few minutes of quiet time for you to write, and then we're going to implement, okay? But you don't need to get that stuff out yet because we got to figure out a couple more things first. You will be answering one of 3 questions, and I will tell you which question you're going to be in charge of in just a minute. Question 1 is, does the mass of the pendulum's bob affect its period? Question 2 is, does the initial amplitude of the pendulum affect its period? And question 3 is, does the length of the pendulum affect its period? Okay, so we're going to do this in a thoughtful way so that we can collect data without making you do every single question. Okay, you with me there? Okay, so what I would like for you to do, I'm going to explain this setup and then I will get you started here. I'm going to start.